Hey everyone, I'm Zach Armstrong with LabCoatz, and today I'll be showing you how I built this high voltage capacitor bank for under $40. Recently, LabCoatz passed the 5,000 subscriber milestone, which can only mean one thing. It's time for a 5,000 subscriber special. This isn't exactly it, but it is related to it. For my 5,000 subscriber special, I've decided to build the world's most powerful non-nuclear EMP device, the flux compression generator. I'll explain more about this monumental device when the time comes, but for now, all you need to know is that I need a very high energy pulse power supply to energize it with. And that is what we're building in today's video. Now, probably the best way to get high energy pulses is with a capacitor. In general though, large capacitors tend to be quite expensive. I mean, look at this. I'm just a broke college student. I can't afford something like this. But I can afford something like this. This is a 450 volt capacitor available on AliExpress for only $3, and it can store about 70 joules of energy. So if I buy a set of 10 like you see here, I'll be able to build a capacitor bank that can store up to 700 joules for under $40. In the world of capacitors, this is a pretty incredible deal. The only downside is the long shipping time, which took about a month in my case. Once I had the capacitors in hand, I set about assembling them into a suitable bank. For a flux compression generator like the one I'm building, high peak currents are key, so we really want the highest voltage possible in order to push the most energy over the shortest period. So for this bank, I'll be wiring all my capacitors in series to give me roughly 4,500 volts and 82 microfarads. In reality, the total capacitance was more like 65 microfarads, which probably explains why the capacitors were so cheap, but you get what you pay for. And 700 joules is good enough for me. Normally, I'd recommend soldering the capacitors together with thick copper wire, but today I felt a little adventurous, so I ordered a set of custom PCBs from this video's sponsor, PCBgogo. PCBgogo is a highly specialized PCB manufacturing company that specializes in quick-turn PCB prototyping and assembly, as well as small to medium volume PCB production. I've been using their services for quite a while now, and so far, they've never let me down. Their customer service is downright stupendous, and every time I work with them, I've received first-class assistance. You can see the PCBs I ordered here, and I think they turned out amazing. If you ever need PCBs manufactured in any quantity, be sure to check them out at PCBgogo.com. Check out the links below for more details. After I soldered up the PCBs, I strung each bank of 2 in series and mounted them inside a 3D printed enclosure for enhanced portability and safety. And speaking of safety, I really wanted some kind of remote triggering mechanism that I could switch safely without as much risk of electrocuting myself. So I grabbed an old 12-volt solenoid from my electronics bin and set it up as a sort of makeshift contactor switch that I could control with a 9-volt battery and this toggle switch. It's a little crude, but it serves its purpose. The completed capacitor bank has 3 wires, one common positive lead, a negative lead to feed energy into, and a contactor switched output. To operate this beast, I simply pull out my trusty 9,000 volt neon sign transformer and connect it to the bank through a microwave oven diode, which rectifies the AC power into DC. Then, using my variac, I crank up the AC voltage to just over 3,000 volts. Remember, the peak voltage of a sinusoidal AC signal is roughly 1.4 times greater than the RMS voltage, so 3 kV actually corresponds to about 4.2 kV in the capacitor bank. To monitor charging, I connect my multimeter in series with the setup and measure the current, which drops from about 8 mA at the beginning to nearly 0 when the bank is approaching a full charge. And once the input current stops dropping significantly, it's time to fire the pulse. To give you some idea of how much power is stored in this thing, here's what happens when you discharge it through a strand of copper wire. Pretty awesome, right? I'll be filming a second video in the next few days that should capture just how much destruction this capacitor bank can dish out. Be sure to subscribe for that. You definitely don't want to miss it. And if you'd like to help support me and my work, consider donating or becoming my patron on Patreon. The links, as always, are down below. A very special thanks goes out to all the dedicated LabCoatz patrons. This channel truly wouldn't be where it is today without them. Stay safe everyone, and I'll catch you next time. LabCoatz, out.